A stolen car does not disappear all at once. It enters a race between the person driving it and the city, quietly watching around them. To the driver, the city may look too large to notice. Too many streets, too many junctions, too many cars moving in every direction. But modern cities are not just roads, traffic lights and parking spaces. They are detection networks. Cameras watch intersections, parking lots record entrances. Patrol cars scan nearby lanes, toll roads log passing vehicles. Bridges, garages, airports, ports and highways all leave tiny traces behind. Most of the time, those traces are background noise. A car passes, a camera reads, a database updates. Nothing happens. But when a stolen car enters the system, ordinary infrastructure can become a citywide search. This is the hidden system behind how cities track stolen cars. It begins with a report. Someone walks outside and finds an empty driveway or a blank parking space where their car should be. At first, the vehicle is not being tracked by a machine. It is just missing. The first step is turning that missing vehicle into data. The owner gives police the license plate, make, model, color, identifying details, and often the vehicle identification number. Once the report is entered, the car becomes part of a much larger system. It becomes a record, a plate number, a description, a status, stolen. That one word changes everything because once a plate is marked as stolen, it can be compared against the quiet stream of vehicle data already moving through the city. The most important tool in that stream is the automated license plate reader, often called an ALPR. A camera captures a passing vehicle. Software identifies the license plate. The plate number becomes text. Then the system checks that number against lists of vehicles that matter. Stolen cars, wanted vehicles, cars connected to active investigations. Most plates pass through and nothing visible happens. But if the plate matches a stolen vehicle report, the system can generate an alert. That alert is the moment the city notices. But an alert is not the same as a recovery. It is only a signal, and signals have to be interpreted. The car may be moving, the plate may need confirmation, the location may already be a few minutes old. So the system has to turn one piece of information into a useful decision. Is the vehicle still nearby? Which direction was it heading? What camera might see it next? This is where tracking becomes less like a chase and more like solving a moving puzzle. What makes this powerful is not one camera. It is the network. A single camera gives one point in space and time. This plate was seen here at this moment, but a network of cameras creates a pattern. This car was seen near a bridge, then near a motorway entrance, then near a retail district. The vehicle leaves a trail not because anyone is following it bumper to bumper, but because the city is remembering where it has been. A stolen car is not just being chased, it is being searched for by infrastructure. That is why time matters so much. A sighting from 3 hours ago may be too old to act on. A sighting from 3 minutes ago may still be alive. The system is asking how recently the car was seen, in what direction, and what might be the next useful point of contact. The city does not need to see every car, it only needs to recognize the wrong one at the right moment. The network is not perfect. Cameras miss plates. Plates can be dirty, damaged, blocked, or unreadable. Traffic can be dense. A vehicle can turn onto a street with no coverage, but even an incomplete network can still be useful because car theft is movement through infrastructure. Stolen vehicles still use roads. They still pass petrol stations, car parks, junctions, bridges, and neighborhood entrances. They still exist inside the physical map of the city. Once an alert appears, the next layer is response. The information has to reach people who can act on it. That might be a nearby patrol officer, a dispatch center, or a real-time crime center where analysts monitor alerts and cameras. A plate reader sees the stolen car. The system flags the location. Nearby units are notified. Other cameras in the area may be checked. Recent sightings are compared. The goal is not just to spot the vehicle, the goal is to turn a sighting into a safe recovery. That word matters. Safe. A stolen car is not just property. It can become a moving risk. A vehicle may be moving through traffic, near pedestrians, or into a residential area. A fast pursuit can create more danger than the stolen car itself. So the hidden system is not only about finding the vehicle, it is about deciding how to respond without making the situation worse. In some cases, officers may follow from a distance. In others, they may wait for the vehicle to stop. In others, cameras and alerts may be used to understand the direction of travel rather than immediately forcing a confrontation. The technology gives information. Humans still have to make judgment calls. Patterns matter too. Stolen cars are not all taken for the same reason. Some are abandoned quickly, some are used in another crime, some are moved for parts or taken across city lines. Over time, investigators can see where cars disappear, where they reappear, which models are targeted, and when thefts spike. A stolen car becomes more than a missing object. It becomes a clue inside a larger map. But license plate readers are only one part of the network. Modern vehicles can produce their own signals. Some have built-in connected services. Some owners use aftermarket trackers. Businesses may monitor fleet vehicles through separate systems. When a stolen vehicle has active tracking, recovery can become much faster. But even then, it is not magic. Location data can be delayed, imprecise, or unavailable. A vehicle may be indoors, underground, or in an area with weak signal. Still, when it works, vehicle tracking adds another layer to the search. Now the city is not only watching the roads, the vehicle may be reporting its own position. Then there is video. Business cameras, traffic cameras, doorbell cameras, car park cameras, and CCTV systems. These are often not part of one perfect central machine. They may belong to different agencies, buildings, residents, and companies. But after a theft, they can help reconstruct movement. A car leaving a street, a vehicle turning onto a main road, or a plate glimpsed near a petrol station can become part of a timeline. This is what many people misunderstand about tracking. It is rarely one dramatic camera catching everything. More often, it is fragments. A scan, a video, a witness report, a GPS ping, a patrol sighting, and a recovery location become useful when they are combined. To the public, the car is either gone or found. Inside the system, it passes through stages: reported, entered, flagged, cited, confirmed, located, recovered, cleared. Each stage turns uncertainty into a little more certainty. At first, nobody knows where the vehicle is. Then the system may know where it was, then where it might be heading, then where it has stopped, then whether it can be recovered safely. There is also another clock running, the clock of damage. The longer a stolen car stays missing, the more likely it is to be damaged, stripped, abandoned, hidden, or used in something else. That is why early detection matters. A quick plate hit can turn a theft into a recovery. A delayed sighting may become only a clue. The best system is not the loudest one. It is the one that notices quickly, shares information clearly, and helps people make safer decisions. But there is a privacy side to all of this. A city that can scan stolen cars can also scan ordinary cars. How long should plate data be stored? Who can search it? What rules protect people who are not suspected of anything? Powerful systems need boundaries. Policies, audits, access controls, and retention rules are part of the hidden system too. Not just cameras and databases, but rules around who gets to use them, when they can use them, and why. The most important thing to understand is that cities do not track stolen cars with one magic tool. They track them with layers. A theft report turns a vehicle into searchable data. Plate readers look for that data in traffic. Dispatchers and officers respond to alerts. Analysts connect sightings. Video fills in gaps. Vehicle tracking may add location signals. Policy decides how the system can be used. Each layer is imperfect by itself. Together, they create a network that can turn a moving vehicle back into a known object. That is the hidden genius of the system. A stolen car enters the city as a problem of motion. It could be anywhere. It could be moving in any direction. But every road, camera, scan, report, and signal narrows the uncertainty. The city may not see everything, but it does not need to see everything. It only needs enough points to turn disappearance into direction, and direction into recovery. To the thief, a stolen car may feel like escape. To the city, It becomes a pattern waiting to be found. The public sees traffic lights, cameras, patrol cars, car parks, and roads. The system sees movement, time, location, probability, and risk. And when those pieces connect, a car that seemed to vanish can suddenly reappear inside the map. This is Systems Atlas. Subscribe to explore more of the world's hidden systems.